Alright, today we are working on direct, inverse, and joint variation. So these aren't too bad. We just have to memorize some formulas for these. So what we're going to look at are the three different types of variations, the equations to use for them, and just how we're going to look at them. So these shouldn't be too difficult. So the first one we're looking at is direct variation. Direct variation was where they're going to state something like y varies directly as x if there is some non-zero constant k such that y equals k times x. So what that means is that it's really just a slope-intercept form where k is your slope and the b value, your intercept, is always going to be 0. So the constant of variation is what we call that k value. So looking at this, we have two different things here. So the bottom part of that is just setting up two different equations and saying how you can relate two different situations. And that's really by eliminating that k value. So if they give you two sets of values, that bottom part will come in handy. But I'll show you how to use that here in a little bit, if necessary. So the first thing it says, if y varies directly as x and y is 12 when x is negative 3, find y when x is 16. So we're going to use that equation, y equals k times x. The first thing you have to do is find k. So we have to plug in y and x that they give us here. It says y is 12 when x is 3. So we plug in 12 is equal to k times negative 3. So we solve for k by dividing by negative 3. So we have negative 4 is equal to k. So that's the constant of variation here. Then it says find y when x is 16. So now we're going to go back to the initial thing and we have, okay, k is negative 4, so it's negative 4x. We plug in x is 16. So we say y is equal to a negative 4 times 16, and we get y is equal to a negative 64. That's our final answer. So all you do is start by finding your k value. You plug in the two values they give you, and you solve for k. And really it's just going to be the y divided by the x. Then you plug that value in along with whatever value they give you. Sometimes it'll be y, sometimes it'll be x. And you solve for the missing piece. The other way of doing it that you use those two things down at the bottom is if you set up both equations kind of at the same time. So you put y over x on one side is equal to, and then we don't know what y is, but we do know what x is. And you could do some cross multiplication here to solve this. You can get negative 3y is going to be equal to 12 times 16. So that 12 times 16 gives us 192. We divide that by negative 3. So y is going to be equal to negative 64, which is what we got before. So both ways are going to do the same thing. You have this option of setting up a proportion between the two, or you have the option of solving for your k value and then using that to find the second y value. So then we have joint variation. Joint variation is where you have three variables now. We have an x, a y, and a z. So this is going to be very similar. They'll give you now two of the three and ask for the third one. But the first time they'll give you three so that you can find the k value. So this one, y varies jointly as x and z if there's some non-zero constant k. So this equation for this one is y equals k times x times z. So you're multiplying those. So similar to last time, we take the other way of doing it, that proportion is taking y divided by both x and z, saying equal to the other y equals y over x times z. So we take a look at what that looks like. So again, it tells us varies jointly, so we know. It says find y when x is 8 and z is 3, if y is 16 when z is 2 and x is 5. A couple of ways of doing this. We could say y is equal to k times x times z. We use these three values because they all go together, and we say 16 is equal to k times 5 times 2. So we have 16 is equal to 10k, which means 1.6 is equal to k. Then we go back and substitute in and find our second values. So we have find y when x is 8, so we're going to have 1.6k times 8 times 3. And then we multiply all of those things out. We get 38.4. Now the other way of doing that is by saying y over xz is equal to y over xz. Now again, we don't know the second one, we do know the first one. So we can say 16 over 5 times 2 has to be equal to y over, what's the other, then we have 3 and 8. So we have 16 over 10 is equal to y over 24. Can reduce these to be 8 over 5 is equal to y over 24. So we get 5y is equal to 192. When you divide that by 5, we should get 38.4 like we did before. So again, both options will work. Those are doing the same thing twice. You don't have to do them both ways, but you do have to do one of those two. So whichever way you like and whichever way works for you is okay with me. And the last type we have is inverse variation. So y varies inversely as x if there's some non-zero constant k. So for this one, when it's inverse, we're going to be dividing. So for this one, it's y is going to be equal to k divided by x. And again, looking at these same things, this time we've reversed it. Notice there's a couple of things different here. One, the x is on top. Two, you put the 1x over the opposite y, and then the opposite x over the opposite y. So let's take a look at what that looks like in terms of problems. So this time they've changed the letters a bit, but that doesn't matter. R varies inversely as t, and r is 18 when t is negative 3. Find r when t is negative 11. So again, I'm going to do it both ways so you can see them. So remember, we start with y equals k divided by x. So for the first one, so I guess I should use the proper variables. So r comes first, so that's going to be, r is going to be equal to k over t. T is going to be our x value. So we have 18 is equal to k over negative 3. Multiplied by negative 3, we end up with a negative 54 for k. So then we go back to this and we say r is going to be equal to a negative 54 all over t, or our second t value is negative 11, and so that's going to be a positive 4 point, it's going to be very close to 5. It's going to be 4.91. And that's our r value. So again, we could do it the other way. Remember, we have r1 over y, t2, r is our x, or r is our y. So we have t1 over r2 is equal to t2 over r1. So it doesn't matter which one's 1 and 2, but as long as you have the t's on top. So we're going to have negative 3. Now negative 3 goes with 18, so 18 has to go in the other denominator. So we're looking for this r, and then we know the opposite t is negative 11. So we cross multiply. So we get a negative 54 is equal to a negative 11r. Divided by negative 11, r is still going to be 0.491. So again, it's doing the same thing, you're just doing them two different ways. So go ahead, right now, there's an example of each. There's directly, jointly, and inversely. Go ahead and try those and see what you come up with. And then I'll put the answers up. Alright, so there are your three answers. We have R was 30 in the first one, R was 28 in the second one, and X was 8 down here. Notice they put X first, so X varies inversely as Y. So it was reversed. So instead of saying Y equals K over X, we'd say X equals K over Y. Alright, and your homework then is going to be 8 through 20 for the evens on page 469.